Good morning, everyone. My name's Andrew Montgomery. I'm one of the distance students in the class. This is my final presentation over an application of data mining in the real world, and for my application, I chose to do a presentation on a paper that used some meteorological data that was collected at the Gaza Strip, and they tried to see what they could learn about the region's weather from that data, and also if any forecasting was possible. The overall purpose of their analysis was to try to take data recorded at weather stations that was recorded daily for every day of the year for multiple years and see if they could perform clustering analysis or association rule analysis that I'll discuss in this presentation, as well as some other methods they tried. And with these methods, they were trying to see what they could learn about the area's climate and also if certain weather conditions could be used to predict future weather conditions. So again, the data they used was weather station data collected at Gaza Strip City, which is located where the red arrow is on the map. And the weather stations recorded observations such as the day, month, and year that data is collected, the daily average relative humidity, the average temperature for the day, the wind speed, wind direction, time of the highest wind speed, and also a rainfall observation. And this data was actually data recorded very long before this paper performed their analysis, and it spans a 9-year period from 1977 to 1985. The group performing this analysis didn't use every observation the weather station could produce, and by that I mean every parameter that was mentioned in the last slide. They weren't so concerned with the year the observations were made, since weather tends to occur in yearly cycles. They also did not see much information gain in wind direction as well as the time of the highest wind speed. So the variables that they looked at were just the month and day of observations, the daily average relative humidity, the average temperature, wind speed, and a rainfall observation. In order to clean up their analysis, they performed some data pre-processing on the observations, and this included filling any missing data entries with linear interpolation estimates. And so an example of this would be if you had a day where you were missing the temperature, you would look at the temperature before that day and the temperature after that day and estimate that the temperature was somewhere in between those values. They also identified 12 outliers that were removed for reasons discussed in that table. And so they hope to eventually be able to leave these outliers in and possibly gain some information from them. But for the purposes of this analysis, they were removed so that no negative impacts would occur from those data points. The first data mining technique they used was cluster analysis with the k-means algorithm we've been using in class. They specifically did a seasonal clustering analysis. So to do that, they used k equal to 4 so that one cluster group would be created for each of the 4 seasons. The two most obvious clusters that get created are blue for winter and the red cluster for summer. The cluster means characterized winter as having colder temps with more rain and higher winds, versus summer being characterized as having higher temps with higher humidity but less rain. As you can see for the seasons of fall and spring, the algorithm had a little bit more difficulty separating those two seasons, likely because they have a lot of the same weather, being transitioning from either winter to summer versus summer to winter. They probably go through the same temperature ranges and also see a fair amount of windiness. But so as you can see with those, there's kind of blue and yellow interspersed with each other for May and also September and October. But overall, this shows a pretty good representation of what the weather would be like for each month and what season that corresponds to. The second data mining method they used was to develop some association rules for the data. They did not explain their methods for this or what algorithm they used, but as you can see, they did have several rules that had fairly high confidence, and with these rules you could predict whether or not it's likely to rain or whether or not you're going to see cold temperatures depending on the month. Past that, you kind of lose confidence as you start trying to work with wind and humidity observations. So this would likely only be useful during the middle of summer or the middle of winter, and during those periods it's also probably kind of obvious what the weather's going to be anyway, but you could see that if you're in the months of December, January, and February, you're likely to see cold temps. And also, if the humidity and temperatures correspond to the summer months, you're also not likely to see rain. In conclusion, their preliminary data mining showed that with these daily observations from the weather stations, you could get a general idea of weather throughout the year and weather during individual seasons, and there was also some potential forecasting that could be done with the data. The authors mentioned that they hope to develop a more adaptive and dynamic data mining algorithm method so that they can more accurately predict forecasting and include the rapidly changing weather conditions into their forecasts. Seeing as we're on the reference slide, that obviously concludes my presentation. Thank you for watching and have a nice day.